So, in the act of doing science, we ask questions, and the questions are of the type of how did it happen, why does it happen, when did it happen, that kind of questions. Something happened or something is observed, a phenomenon is observed, and then we ask such questions. And then I said that the standard way of answering or attempting to answer the question is to form hypothesis. So, today we will be discussing the topic forming a hypothesis. How to form a hypothesis, what are the scientific ways of forming a hypothesis, and so on. But we have to understand that in answering a question, the standard method is to make a scientific guess, not a scientific guess, but many scientific guesses, and to eliminate the wrong ones. And in this pursuit, the method adopted by a scientist is quite similar to the method adopted by a detective when such a person is called to find out the perpetrator of a crime. Just imagine a situation like Sherlock Holmes. He is sitting in his chamber, and there are footsteps on the stairs. Somebody comes in and reports a crime has happened last night, and Sherlock Holmes goes there and does something. What does he do? He, on the first day, looks for the clues. A footprint here, a bit of fingerprint there, maybe cigarette butt put somewhere, or some object located in a place where it is not supposed to be located, and so on and so forth. Those things he observes and then comes back home. These form his clues, the clues on the basis of which he would then, after he comes back home, he would then form hypothesis. He would guess that this must have happened, that must have happened, or when the clues are insufficient, then he would be able to formulate many hypotheses that are consistent with the clues. So, he has a bank of such hypotheses, and then his task would be to eliminate the wrong ones. And then his logic line of argument would be that if this hypothesis is true, then I must find this. If that hypothesis is true, then that must happen, and so on and so forth. And then he goes and checks. And that way, he eliminates the wrong ones, and finally, the day he announces who is the criminal, that day he has basically eliminated all the other hypotheses and zoomed onto one. This is how science also works. Science also, whenever we have a question in mind, we first try to find out the initial information that is available about that event or a phenomenon. People may have observed it, people may have studied it, people may have experimented on it, measured something. So, those form our clues. And when we have the clues in hand, then we proceed to form the hypothesis. Okay. So, the first task is in forming the hypothesis, the first task is to look for the clues. So, when we have the task of looking for the clues, we basically try to find out what is already known about that phenomenon or event. For example, if you are talking about if you have question regarding the origin of the solar system, then the initial clues would be whatever had been observed, that all the planets move in elliptical orbits with the sun at a focus. The fact that the sun is much bigger than the planets, and so on and so forth. The observed thing, the fact that the solar system is almost co-planar, all the planets move in the same plane, in the same direction, not that it is one is moving in this direction and moving in that direction. So, these are the initial clues on the basis of which a scientist would provide the hypothesis. So, the first step is to look for the clues, and then you have to formulate the hypothesis. So, second step is to formulate the hypothesis. I will use hypothesis, that is the plural of hypothesis, because when the clues are not sufficient to zoom onto one, then there would be a larger number of hypotheses that would be able to satisfy the clues. But when you formulate the hypothesis, there are certain immediate requirements. Unless you satisfy those requirements, the hypothesis cannot be called scientific. And as I said, the hypothesis is also a guess. There has to be a difference between a scientific guess and a wild guess. Every wild guess is not scientific. So, there has to be some requirement to be fulfilled by the hypothesis in order to be called a scientific, in order to attract the attention of other scientists. Otherwise, people will ignore that guess. The first requirement is a hypothesis should be a hypothesis, sorry, should be consistent with the clues. A hypothesis should be consistent with the clues. So, if you have initially located a few clues, then the hypothesis should be such that if that course of event did happen, then the clue that has been found should be true. So, the clue should be a logical consequence of the hypothesis. So, whenever we did the logic, that way we showed how to form the logical structures. A premise leads to a conclusion. If the hypothesis is true, the clues should be the conclusion, and that way we have to provide or formulate the hypothesis. So, initially we find clues, and on the basis of the clues we formulate the hypothesis. And when the clues are insufficient, there would be a large number of hypotheses that will be able to satisfy the clues. So, I said that the hypothesis should be consistent with the clues, which means that the clues should be a logical consequence of the hypothesis, and the logical structure should be very clear, and that should be based on what is already known about the laws of nature. So, a hypothesis, add to that the laws of nature that are known, leads to a conclusion, and the clue should be that, should satisfy that. Now, in some situations it is possible that that the intermediate course of logical progression, which means the use of certain laws of nature, it may be that at some point of time a particular law of nature is not known, and therefore, the hypothesis does not completely corroborate with the or correlate with the clue. It is possible. In that case, should we abandon the hypothesis? No, but we should have some doubt about it. We should look at it with some suspicion, but at least if the scientist very clearly states that this hypothesis will lead to the clue if this is a law of nature, this is a missing piece of the jigsaw puzzle, and then people might look for that particular law of nature, then and if that law of nature is found, then the hypothesis becomes a sound scientific hypothesis. Till then, it is just a provisional hypothesis. So, hypothesis should be consistent with the clues, but at any point of time it is possible that it may not be completely consistent, in the sense that some piece of information might be missing, and then till that gap is filled, that hypothesis will be taken as a provisional hypothesis, not not at par with the other hypothesis that may have found. The second thing is that B, a hypothesis should be based on material processes and phenomena. This is the demand of materialism. So, we cannot hypothesize that a particular event happened because somebody willed it, it happened because some miracle. No, those things are out of the question when we deal with science. So, a hypothesis should be based on material processes. For example, when people started forming hypotheses about the origin of the solar system, a very strong current was that the solar system had been created by somebody. But no, scientists said that no, let us try to formulate hypothesis based on material processes and phenomena. And that is how we finally came to an understanding about the origin of the solar system. The third requirement is that it should have some testable predictions. It should have testable predictions. Testable means, as I have already said, that if you have a premise, you apply valid logic, you come to some conclusion, that one has to be testable. So, this structure is important. The premise in that case is the hypothesis, and if you apply valid logic on that hypothesis, then you should be able to arrive at a conclusion that would be the expectation from the hypothesis, and that expectation can be experimentally or observationally testable, should be. That is a hard requirement of why? Because it should be falsifiable. In the last class, I explained the concept of falsifiability, and this is exactly where it is applied, that when a hypothesis is proposed, it should be conceivable how to falsify that, under what observations and a hypothesis or a theory can be proved false. At this point, notice one thing, that every good theory is restrictive, in some sense prohibitive. It prohibits certain things from happening. For example, a good theory, example of a good theory is a Newton's theory. It prohibits things from going upwards. Apple will not go upwards, it prohibits. And the simple falsifiability criterion would be that if you ever see an apple going upwards, the Newton's theory is definitely false. It prohibits any motion of a particle or an object under center force in any fashion other than an ellipse. A circle is a special case of an ellipse in that sense, but nothing other than it has to be conic section. It has to be conic section. There are a few conic sections, they are possible, but nothing else. No other form of motion other than conic sections are possible. If you ever see any motion under that central force which is different from a conic section, then definitely the theory is false. So, these are easily testable, falsifiable theories. Similarly, all hypotheses should be falsifiable. Okay. So, these four are the demands, are the requirements. Without these, a hypothesis will not stand as a scientific hypothesis. It will just be a wild guess. But as I told you, in most situations you have a large number of hypotheses that would be conforming to the clues. So, we have to always use plural hypotheses, a large number of hypotheses. So, when you have a large number of hypotheses each claiming to be explanation of some phenomenon, you have to test. And when you do the test, we normally prioritize the hypothesis. Which one I will test first, which is a good candidate, and so on and so forth. So, when we prioritized, then we have to have some kind of desirable criteria. These are not the requirements, but some desirable criteria. Okay. Let us enumerate the desirable criteria then. These are the requirements, and let us go to the desirable criteria. The first one is fruitfulness. Fruitfulness means the hypothesis was proposed in order to explain certain event. But if that hypothesis explains only that event and nothing else, then it is not fruitful. But if it has a larger applicability, so that it helps to explain more things than for which it was primarily proposed, then it is fruitful. So, if there are a number of hypotheses that a scientist has to check, the one that has the largest fruitfulness would be the one that is sort of preferred by the scientist. So, other things being equal, one sort of prefers the hypothesis that is most fruitful. So, what is fruitfulness? The applicability or the usefulness of the hypothesis in explaining phenomena other than the one for which it was initially proposed. Okay. Second is scope. Scope is where every hypothesis will have a testable prediction, but the testable predictions, if a hypothesis has many testable predictions and another hypothesis has a small number of testable predictions, then it is easier or more meaningful to test the one that has a larger number of testable predictions. Okay. So, firstly it should be such that it should be testable under varied circumstances. And the varied circumstances mean for different situations it should have different testable predictions. Different experiments should be able to test it. Then it has a larger scope. Okay. And other things being equal, we will prefer the one that has a larger scope. The third is simplicity. Simplicity is, by common parlance, you might think that the one that looks very simple, that is the simplicity. No, it is not so. A simple hypothesis is the one that makes the least number of a priori assumptions. The more a priori assumptions you make, the more complex it becomes. It loses simplicity. So, again, other things being equal, a scientist prefers a hypothesis that is simpler, in the sense that it makes lesser number of a priori assumptions. And finally, we have to come to the last one, that is D, it is conservatism. Conservatism means so far through millennia of human history, we have built a body of knowledge, and there are certain theories that have been tested, that are now a part of the human body of knowledge, and the hypothesis that you are proposing should be consistent with the existing body of knowledge. Existing body of knowledge that has been tested, and there are reasons of believing that these are dependable. When a hypothesis is compatible with the existing body of knowledge, it is called conservative. Now, it may be so that under certain situation a scientist makes or proposes a hypothesis which is not consistent with the existing body of knowledge. It may be so. When that happens, again scientists will look at it with some suspicion, because there is some bit of uncertainty regarding the proposition it makes. Only when that bit of additional knowledge is obtained, then we say that this is a scientifically stated hypothesis. Otherwise, we look at it, we do not jettison it, we do not abandon it right away, but we take it with a pinch of salt, and we look at it with some suspicion, because it is not consistent with our existing body of knowledge. But we do not abandon it right away, because it is possible that some part of our existing body of knowledge may be wrong, may need to be corrected, and maybe that hypothesis, when ultimately tested, will lead to that correction. Since that possibility exists, we do not outright reject a hypothesis. So, these are the mandatory requirements when proposing a hypothesis, and these are the desirable criteria when proposing a hypothesis. Now, as I said, that in any given situation there would be a larger number of hypotheses, and then scientists will go ahead to test with the specific objective of rejecting the wrong ones, not proving the one that is correct, because that cannot be done. So, rejecting the wrong ones. So, all scientific experiments are carried out with the express objective of rejecting the wrong ideas. Now, whenever we propose a hypothesis, we always propose two hypotheses. One is called the null hypothesis, and the other is called alternate hypothesis. If I am talking about a particular phenomenon, null hypothesis would say the phenomenon does not happen, and alternative hypothesis will say the phenomenon happened. If I am talking about the cause of certain event, a particular cause, the null hypothesis will say that that is not the particular cause, and the alternative will say that that is the cause. So, that way we have to formulate the null hypothesis and the alternative hypothesis. The null hypothesis is normally called H naught, and the This one is called H1. In some books, you will find null hypothesis is given H and H prime, alternative H prime, and so on and so forth. There are various notations, but I prefer to use the notation of H naught and H1. So, for every hypothesis, there will be a null, there will be an alternative. And when we actually test the correctness of the null hypothesis. I will come to that when we come to hypothesis testing. So, then we go on to testing the hypothesis. So, ultimately we formulate the hypothesis and then we test the hypothesis.